Please welcome Dr. Jeong Kim.
Good morning. It is really an honor to appear before this exceptional audience and to contribute to this colloquium on excellence through innovations. Above all, I'm really excited to be here to pay my respect to Nariman Fabadin and express my delight in his appointment as the president of this venerated institute. Nariman sets the bar really high on everything he does and inspires those around him to do likewise. I know that bringing someone like Stephen Chu to this colloquium is in part demonstration of the aspiration and powerful affirmative signal to entire Stevens community. I have no doubt that under his leadership, Stevens will become increasingly be seen as an institute where good students come to be great. And this brings me to the very topic that I would like to explore with you today: achievement of great things through great innovations. Great innovations, what exactly does that mean? And where are they to be found? At the close of the 20th century, John Brockman asked the web community to nominate the greatest single invention of the past 2,000 years. And suggestions include plow, printing press, clock, television, and contraceptive pill. All good candidates, but are they simply great inventions or truly great innovations? Is there a difference? I would say that the human inventions leads to expansion of knowledge. That knowledge might be of a universal nature, an element of larger truth that very likely the product of a scientist or philosopher. On the other hand, the knowledge might be of a more functional nature with immediate applicability to a task. It is likely to have resulted from efforts of craftsmen or entrepreneurs. And between them is the land of technoscience, inhabited by every resourceful engineers. Innovators, however, do not seek to expand the knowledge for its own sake. Theirs is a pursuit of discovery that will register impact on markets and on society. And that impact will result from satisfying the unmet needs of those markets. The greater the need, the greater the potential for innovations. So I offer my rather first obvious observations. Great innovations satisfy great need. Often, core needs can be masked by other behaviors or remain within the subconscious realm of consumers. As a result, the ability to recognize or reveal latent market demand is crucial. As is sometimes said, one does not decide to build a bridge by counting the number of swimmers crossing the river. Consider the latest great innovative product from Apple, iPad. Was there throughout the order of time, or at least since the beginning of the information age, some primordial human needs for an iPad? If so, why wasn't the tablet PCs marketed by Microsoft and others back in 2001 more successful? You may remember this device. They were essentially the portable PCs where the screen would rotate and transform into a pad, and they offered the capacity for data entry with the stylus. Not only they shared a similar form factor with iPad, but they were envisioned to share many of the same capabilities. Then again, there were quite a few capabilities that they didn't share. Why not? Well, consider the frame of reference for the designers of the tablet PCs. It wasn't a television or media player. It wasn't an ebook. It was the laptop. Specifications were in large part extrapolated from the experience of laptop users. Architectures were borrowed and platforms reused. The engineers of the tablet PCs were trapped by their own experience. This curse of knowledge blinded them to other potential frameworks and market needs. At Bell Labs, we long ago adopted a cross-disciplined approach for research to ward off this curse. We believe that the cross-fertilization of ideas and perspectives, along with cultural and other forms of diversity, lead to a less restrictive view of solutions for a broader set of needs. Of course, Nariman knows this principle as well and calls his approach hypernated engineering. To quote from Noam Augustine's book, Is America Falling Off the Flat Earth? At the University of Maryland, his leadership and approach were embodied in a new engineering building where nanotechnology, bioengineering, and information technology would share common space for labs, instruction, and discourse. Another explanation for the fate of the tablet PCs is that there was no explicit demand. that this demand only materialized as a result of another innovation. By the way of example, consider elevators. Elevators had existed for thousands of years, but until Elisha Otis introduced the elevator brake in 1854, they were only used for cargo. This device could bring a free-falling elevator to a complete stop in inches should each cable break. Otis's safety innovation gained widespread attention at the World's Fair that year and unleashed a huge demand for the people carrying elevators. And as a result, our urban landscapes were totally transformed. In an analogous way, perhaps it was the applications or apps for short, or the notion of App Store that unleashed the demand for an iPad. Or perhaps it was the success of its little cousin, the iPhone. As you can see, the ability to grasp and define the fundamental market need is far from simple. Adopting a broader market radar or accounting for the dependencies is likely to help. But success can be jeopardized by yet another factor, or too prevalent within the technical community. It turns out that as engineers, many of us have something that I call innovation dyslexia. Victims of this condition design a solution which they become quite enamored and then infer market needs that solution could satisfy. Innovation dyslexics also tend to distort the magnitude of those needs. Unfortunately, they are likely to generate little in the way of great innovations. Let me give you an example. In the US telecom industry in the late 1980s and 1990s, investments poured into a technology called ISDN. Back then, consumers could access data by means of 28 kilobits per second modems. The basic ISDN service would bump that rate up to 64 or 128 kilobits per second. More importantly for telcos, it promised more efficient operations. Marketing organizations pitched a bounty of new revenue-generating ISDN services related to remote education, improved healthcare, civic engagement, and the like. But doubling or even quadrupling bandwidth failed to have any substantial impact on the market needs related to these or most other areas. The added cost for the ISDN service, along with the requirements to purchase new device, didn't help either. ISDN may have been inflamed the hopes and desires of the telcos, but not the market. It was perceived as an incremental solution. Truly great innovations are more likely to emerge from aspirations for solutions that are orders of magnitude beyond the incremental. Such innovations are disruptive. They are not only meet the fundamental market needs, they usher in whole new dimensions for improving human experience. Now, let me offer another observation. Creating great innovations require the right set of assets. And remarkably, some of these assets are nowhere to be found in the corporate balance sheets. Look closely. You will find land and buildings, goodwill and receivables, but you will be hard-pressed to find the people on the balance sheet. And I'm not talking about the cost for employees accounted for on the income statement. Rather, I mean the asset value of the people, the best people. A few decades ago, the globally renowned electronic company Philips turned its attention towards Bell Labs. They wanted to understand why Bell Labs was more successful than Philips Lab in generating great innovations. Philips observed that both labs sought out the best and brightest graduates. But whereas Philips recruited from local universities, Bell Labs recruited globally. In fact, traditionally more than 50% of Bell Labs researchers were born outside the United States. Bell Labs understood the value of hiring the very best people and cast its net worldwide. In the same notion is echoed by Jim Collins, the author of the book Good to Great, in his succinct admonition, first who, then what. Many of the innovations I have observed firsthand were based on applied research done by those outstanding researchers. And the agenda for such research was shaped by the ongoing interaction of researchers with the market in meetings with customers, policymakers, and our own business division colleagues. These conversations help us to validate assumptions on what will likely be emerging needs. The intensity of ongoing market interaction is a key distinction for industry-based research versus university-based research. For in the latter, the imperative is generally to expand knowledge in a particular technical discipline. In industrial research, knowledge expansion is more mission-driven. While finding answers and discovering new knowledge is important, the real challenge in industrial research is knowing what questions to ask, which problem needs to be solved in the first place. So let me offer an example of how industrial research serves as a catalyst for information. In the 1990s, the huge transformations were underway in communications networks, changes that would enable massive increase in bandwidth. Two innovations in particular play a key role. The first enabled the faster transmission rates over optical fiber, which was at the time trying to evolve from 2.5 gigabits per second to 10 gigabits per second. At this increased transmission rate, dispersion would become a major problem. By dispersion, I mean the tendency of different parts of the light signal to travel at different speeds. Finding a solution to this problem, manufacturers of the optical fiber cables had released new product to compensate for dispersion. The fibers in these cables were designed and engineered to have a zero dispersion at 1.5 microns, the wavelengths where most of the optical traffic was centered. Thus, promise of 10 gig transmission could be realized. The second innovation allowed a multiple wavelengths of light to occupy a single fiber, a technology known as wave division multiplexing, or WDM. The prevailing assumption was that with WDM, 8 or 16 wavelengths could traverse these zero dispersion shifted fibers. But things didn't work out. Expected throughput just wasn't materializing. At about the same time, two Bell Labs researchers, Andy Crabtree and Bob Koch, were exploring what was then a relatively obscure subject of nonlinearities. But recognizing the market interest in deploying the WDM solutions, they began to redirect their research to focus on new questions. And then Bob soon discovered the reason behind the disappointing results of the initial WDM systems. And sure enough, it had to do with optical nonlinearities, resulting in crosstalk among multiple light signals traveling in the same fiber. Their solution was not to use the zero dispersion shifted fiber, but to introduce just the right amount of dispersion at 1.5 microns to compensate for the nonlinearity effect, thus removing the crosstalk. The outcome of their research was a new fiber called TrueWave, which in turn enabled the promise of WDM to be fulfilled. Another asset that you will not find on any balance sheet is culture, the right culture. A good example of how culture affects innovation can be found in Dima Adamski's commentary on the origin of RMA in his 2010 book, The Culture of Military Innovations. RMA, or Revolution in Military Affairs, refers to the way in which armed forces are transforming through the use of new technologies and organizational concepts. For example, RMA requires full integration of precision-guided missiles, surveillance drones, and real-time command, control, and communications technologies. The concept originated in the Soviet Union during the 1970s, but the Soviets' rigid military bureaucracy was unable to adapt to the degree required by RMA doctrine. RMA then found its way to the United States. Given US military's affinity for technology-based solutions, you might think that it would be the first to operationalize RMA. But the bottom-up entrepreneurial culture of the US military, in fact, made it resistant to the highly centralized coordination required by RMA. The first country to actually use RMA was Israel in its 1982 clash with the Syrian Air Force in the Lebanon's Bekaa Valley. Israel's military culture was born out of continuous resource constraints and constant threats. It was defined first and foremost by creative adaptability. By implementing RMA, the Israelis overwhelmingly dominated their battle. While we can debate where and when this innovation materialized, it's quite clear that culture of this organization played a key role in its ability to have impact. Don't know what happened here. Technology problems. Well, let me go on. Closely related to culture is leadership. Great leaders can lead great people to achieve great innovations. As the Silicon Valley folklore goes, Steve Jobs paid a visit to Xerox PARC's research facility in 1979. There he saw PARC engineer Larry Tesler move a cursor across the screen with an aid of what was called a mouse. As the cursor moved over an icon on the screen, the Tesla clicked one of the buttons on the mouse, and the world changed, at least from the perspective of Steve Jobs. Upon returning from his visit, he met with an industrial designer and described what he wanted. While the Xerox mouse would cost $300 to build, Jobs required that his mouse to be manufactured for $15. The Xerox mouse would break within a few weeks due to clogging effects of dirt and dust. Jobs required that his mouse last for years. Jobs had a vision. It came to life even as he was catching Tesla move and click. He transformed that vision into specific challenges for his talented people. In other words, he provided leadership. The pursuit of great innovation often means setting the bar really high. And at this height, the likelihood of failure is always present. It follows that to succeed in achieving great innovations, one must also succeed in dealing with failures. And to succeed in dealing with a failure, we must confront the ultimate failure, that is, failing to learn from our mistakes. There is indeed a wisdom in Thomas Edison's oft-quoted response to questions asked about his failed light bulb experiments. Edison had not failed, he said. He had found 10,000 ways that wouldn't work. To create disruptive innovation, we need to take risks. Like Edison, we'll fail. And like Edison, we need to learn. But some organizations unknowingly erect barriers to learning from failures. Corporate recognition programs in particular often breed such obstacles. Consider the common practice of rewarding employees based on their achievement of mutually agreed objectives or key performance index, KPIs. Such programs can cultivate a risk-averse approach. When the prevailing attitude is failure is not an option, a pervasive dynamic overtakes the process of defining mutually agreed objectives. They will be constrained by what was achieved in the past, not informed by the opportunity of what might be achieved in the future. They will lead to predictable outcomes. But for the market realities defined by change, such outcomes will be inadequate. Alternatively, consider recognition programs that focus more on behaviors. These programs can be more accommodating of change and risk-taking. They are more likely to allow an employee to learn and benefit from failures. Recognition programs often suffer from yet another limitations. They are subservient to the calendar. The imposition of a calendar, say an annual performance review, can diminish the would-be innovator's appetite for risk-taking. When the month of the truth arrives, successes had better be registered. For researchers to offer promise, let alone the hollow sound of failure, will do little to assure professional growth or appease the board of directors. But the pace of research is not synchronized to quarterly research, and the market's windows of opportunity are not beholden to the physical calendar. Fortunately, there are ways to accommodate these two dictates of time. For example, we could evaluate researchers on both 1-year and 3-year timeframes. The 1-year term determines the bonus, while the 3-year period decides rank and salary. The process bespeaks a commitment to investing in the early, risky stages of innovation. It makes clear that while failures may result, it is expected employees will learn from them and grow. But ultimately, there is a deadline for success. One of the most difficult challenges in learning from failure is to know when a failure actually occurred. People naturally seek positive outcomes and set about trying to prove that experiment works and has value. It is here that cognitive dissonance is alive and well. Often, even when the evidence suggests otherwise, team pushes on. And it is only the success of rivals pursuing other methods that brings home the harsh truth. To succeed in dealing with failure is to acknowledge when the failure has occurred and close the door promptly on the initiative. Sounds reasonable, of course. But shouldn't we also reward tenacity and intuitism in our talented people? To close the door or not, this is an all too common dilemma, and one that demands great judgment. On one hand, insidious cost of not curtailing a failed approach saps creative energy. On the other hand, the failure to support the very risk-taking behavior that you have professed to encourage might carry a cost in lost faith and frustration. A dialogue that frames the issue in terms of opportunity cost can be helpful. There is a significant opportunity cost of not having the use of talented individuals on the project with greater promise. Let me offer an example. Several years ago, researchers at Bell Labs came up with the algorithm for addressing network security. The potential was exciting enough that we created a venture to which we could productize those algorithms. For various reasons, venture did not fare well, but the team wanted to continue. Even so, I pulled the plug. And when I did, those researchers recognized that the algorithms could be used in other ways to provide insight into resource impacts of applications running on the wireless networks. The beauty of their design was that they could do this without employing intrusive methods like DPI or deep packet inspection. These researchers now devoted themselves to what became another venture, a product we call Wireless Network Guardian, or WNG. WNG drew strong interest from wireless carriers who were struggling to manage the impact of more demanding smartphone applications and tablets. YNG is now core to our mobile network management platform. So, I have proposed 3 attributes to support great innovations. First, understanding the market needs. Second, assembling the talented people with appropriate market access, culture, and leadership. And third, building the capacity to manage and learn from failure. I would like to add one more, the flexibility to change. Change means different things to different people. The cosmologists measure change by a clock whose hand sweeps over millions or billions of years. Archaeologists tend to think in millennia. But the clock that I'm thinking of measures in the time which our expectations are formed and our actions are bounded. That period of time at its longest can be marked by our lifetime. During that time, we experience and adapt to a huge number of changes in factors such as biology, environment, or society. Among the most influential of such factors are knowledge and information. At the beginning of the 20th century, the amount of new information one might need to accommodate would double over average lifespan. The flexibility to accommodate this rate of change was apparently not beyond most of us. Today, according to several studies, information is doubling every 3 or 4 years. At this rate, over one's lifetime, information would not just double, it would increase by hundreds of thousands or millions of times. Over the past decades, we have responded to this information onslaught by accentuating our degree of specialization. We see this in academics and in many of today's professions. However, I believe this one-dimensional response, the pursuit of greater depth in increasingly narrow discipline, will fail to provide the quality of innovation to which we aspire. In addition to going deeper, we must sometimes go wider. For the leading edge of discovery and innovations often occurs at the intersection of diverse disciplines. When it comes to embracing change, my favorite quote is from Eric Hoffer. Quote, "In times of change, learners inherit the earth, while the learned find themselves beautifully equipped to deal with the world that no longer exists," unquote. At the organization level, we have already touched on the importance of learning from failure. We should also be wary of another paradigm of success leading to a failure. Let me explain. Most successful companies, having achieved a technical innovations, will seek to innovate in their business practices as well. However, an organizational gestalt has set in that steers the company in its current course and speed. Borrowing a term from psychology, organizational gestalt represents a combined impact of how a company is organized, how company's processes works, and how each management style shapes the behavior on what has been rewarded in the past. Resisting initiative aimed at reform, such initiative will likely to keep the company aligned with the past. A former provost at MIT, Bob Brown, once replied when asked about his efforts to change the MIT curriculum, quote, "You just don't realize how difficult it is to overcome 100 years of success and excellence," unquote. When significant changes do occur and market becomes less predictable, well-intentioned and proven practices will soon be at cross purposes with the market necessity. Today, where the one sure constant is not just only change, but increasing rates of change, organizations must build in the framework for their own reinvention. Coasting is not an option. Academic institutions, too, must adapt to this reality. What, after all, is to become a university, an entity that study life as a guild for students seeking to learn the law, medicine, religion, and philosophy in the Middle Ages. Knowing Nerman as I do, I'm confident that Stevens will remain at the forefront of efforts to answer that question and explore new options for keeping our academic institutions highly relevant. As I noted earlier, he's a great believer in interdisciplinary research. He recognizes the value of collaborations between university and industrial labs. It is a view that I share based on many collaborative research initiatives in which Bell Labs participate, and it is a view increasingly shared by public agencies seeking to promote innovations. Achieving greatness through great innovations is a worthy objective for all of us. It can be achieved by seeking out solutions to satisfy a need, not the inverse. It will require having right assets on board, and it will also require summoning the courage and wisdom to learn from failures, an admonition that might seem trite, but is so often disregarded when the commitments of the first fiscal quarter or fiscal year loom over us. And finally, it will result from challenging your own orthodoxies for how you innovate in the face of radical change. In such a world, the value that informs so many of your traditions must be reassessed. Some will prove worthy of holding on to and strengthening, but others may no longer be as relevant as they once were. Who better to conclude these thoughts on achieving greatness through great innovations than Leonardo da Vinci, the very personification of Renaissance, master painter, architect, engineer, mathematician, musician, and artist. But above all else, he was the master innovator, so let us pay heed to his message. Knowing is not enough, we must apply. Being willing is not enough, we must do. Thank you.